All right. It's like Algebra 2, Lecture 215 and 16, OASA 2F12. The student will use base 10 logarithms to solve exponential equations, rounding to the nearest 10,000th. That's what our plan is going to be. And we've been studying logarithms here recently, their properties and whatnot, and now we're going to use logarithms to solve equations that have a variable in the exponent. And this will take an equation that looks difficult and turn it into something that's pretty simple. So here we go. Let's take a look at what we're doing. It says solve these equations, round the answer to the nearest 10,000th. That is the fourth decimal place. So what we're going to do is look at our equation, and we're going to solve it just like we did back in pre-algebra. And we're going to try to isolate the variable. And the first thing I look at when I see this, I say, well, the variable is in the exponent, so I know that I'm going to have to use a logarithm, and I'll show you that you'll know that too here by the end of this lecture, hopefully. I want to isolate the term that has the variable in the exponent. So the first thing I'm going to do is add 5 to both sides. I want this by itself. So I'm adding 5, and I'm hoping I don't mess up my arithmetic, something you guys know I do from time to time. I'll try not to. I bring down 12 to the a power is equal to 56.9, if I do that correctly. Now I look and I say, well, 12 to some power is 56.9, and I want to round it to the 10,000ths. So I want 4 decimal places precision. So what I'm going to do is take the log of both sides and then use the power property. Watch how this works. If I take the log of this side, it'll look like this. And I take the log of this side. All you do to take the log of both sides of an equation is write the word log. Scooch this over a little bit this way. There we go. So I've taken the log of both sides. And now if we look at this right here, remember the power property? We studied the properties. This power property, I can use the power property to move this exponent from a position of an exponent to a position of a coefficient. So that's what I'm going to do. I'm going to take this a, my variable that I'm trying to solve for, move it from an exponent to a position of a coefficient. So I'm going to wind up with, I'm going to scooch this down a little bit, a times the log of 12, notice it got physically a little bit bigger, is equal to the log of 56.9. Okay. Now, in pre-algebra, if I said, well, if we want to solve for this and we have a multiplied log 12, how do you get rid of a multiplied log 12? And you guys would say, well, we would divide by log 12, and that's exactly right. We're going to divide both sides by log 12, and that will isolate our a. So I wind up with a is equal to this right here. Whoops. That. I'm going to rewrite that. And now I can enter that into my calculator and round it to the 4th decimal place. That's the 10,000th position, which is what they asked us to do in the instruction. We're going to round to the nearest 10,000. So I'm going to go with my calculator, log 56.9 divided by log 12. Now, if the logs get a little more complicated and you're doing that division and you're not getting one of the choices that's offered to you, try putting, in this case you won't have to, but if it happens like that, try putting your numerator and denominator in parentheses and see if that will enable you to find one of the correct responses, find one of the responses that you're looking for. So let's see what we get when I plug this in. I'm not going to use the parentheses because we don't need to. But if I got the wrong answer, if I couldn't find one of these, the multiple choice solutions there, I would do that. So I got log 56.9 divided by log 12 equals, I get 1.62633, blah, 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 blah. And I want to round it to the 4th decimal place. That's the 10,000th. 2, 3, 4. So I'm looking at this one. If this is 5 or larger, I'm going to round it up to a 4. If it's 4 or less, which it is, I'm going to just leave it alone. So that's what I'm going to do. Whoops, erased part of my 3. Let's write that back in there. There we go. So A is approximately 1.6263, which means that if I go 12 to the 1.6263 power, subtract 5 from it, I should get very, very, very close to 51.9. Okay? Let's take a look at another one. Hopefully that made sense. We're going to do the exact same thing. Set my calculator down, get a drink of water. Okay, I'm going to try to get this by itself, that V. I've got to multiply 7.2, so I'm going to divide both sides by 7.2. That'll give me 12 to the V is equal to, I'm just going to leave this. I'll leave it just like that, so I don't have a big long decimal. Now I'm going to take the log of both sides. See if I can scoop that over a little bit. I can, yay. Now, to get this V, I'm going to do the exact same thing I did here. I said, hey, I got a variable in the exponent. I've isolated the term that has the variable in the exponent. So now I'm just going to take the log of both sides and use the power property. I take the log of this side by just writing the word log next to it. I do the same thing over here. And now I use the power property. I'm going to move this from a position of an exponent to a position of a coefficient. V log 12 is equal to log, and you will want to put this in parentheses, 67 divided by 7.2, if I haven't miswritten anything. Definitely want to put that in parentheses, because if you don't, it'll take the log of 67, and when you hit divided by, it'll take the log of 67 and then divide that by 7.2. We don't want that. We want the log of this quotient. And now I'm going to divide both sides by 12, log 12 rather. Dividing both sides by log 12. And there's my answer. Right here, that's the exact answer that I could raise this to that would make it exactly 67, but we want to round it to the nearest 10,000. These will cancel and give me V is approximately equal to whatever this mess is when I get it into my calculator. I'm going to go log parenthesis 67 divided by 7.2, close parenthesis, divided by, or you can hit your fraction bar, it doesn't matter, log 12, and then see if that's among my choices. It should be. If it isn't, then I'll put this in parentheses, but it should be. Where's my calculator? There it is. Let's see what we get. Log parentheses 67 divided by 7.2, close parentheses, equals divided by log 12. Equals, I got 0.89766. I hope that's right. I'll look here in just a second. 0.8976641. And I want to round it to the 4th decimal place. That's the 10,000th. So that's 1, 2, 3, 4. Make sure I've copied that correctly. And so this will round up to a 7 if I haven't made any mistakes. I'm going to round that to a 7. And then check to see If I got it right. I hope I did. Otherwise, I'll have to go hunting for my mistake. Problem 2, 0.8977. Yay! So, see? So that means if I raise 12 to the 0.8977 and then multiply it by 7.2, I'll get really, really close to 67. Neat little tool for solving equations that have variables in the exponent. It's kind of close there. Move this up just a little bit. It's not working with me here. Shucks. There we go. Okay, here we go. I'm going to do the same thing. I'm going to treat this kind of like a pre-algebra problem. I want to get this 10 to the p power by itself by adding 6 to both sides. Then I'll take the log of both sides because I have my variable in the exponent. So I'm going to add 6 to both sides. I'm going to do that in my head. This is going to yield 10 to the p power if I add 6 to both sides. And 86 plus 6 is what, 92? So I did that in my head. Now I'm going to take the log of both sides. The log of 10 to the p is equal to log 92. And this is base 10. Yeah, I'm not showing the base, so it's base 10. I'm going to use the power property now. I'm going to move my variable from a position of an exponent to a position of a coefficient. That will give me p log 10. Log 10, that's equal to 1. Is equal to log 92. It makes me feel like I've made a mistake. I hope I haven't. I'm going to divide both sides by the log of 10. Which is 1. And that should give me p equals whatever this is. I'm going to enter that into the calculator. I'm writing uphill today. Log 92 divided by log 10 equals 1.96378 blah 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 1.9637878 and I want to round it to the 4th decimal place. So since this is a 5 or more, I'm going to round that up to an 8. That 7 will become an 8. And then I'll look and see if I've made any mistakes, and hopefully I haven't. Take a look. This is problem 3, I think. Yeah. 1.9638. Yay! And that should be an approximation symbol, I'm sorry, because we rounded, and that means we're approximating. I think I did that on the other ones. Yay. All right, we've got one more, basically the same thing. These are the types of problems. Have a m plus 5, we'll have to do something just a little bit different, but it's not much at all. I'm going to subtract 6 from both sides. I'll do that in my head. 20 to the m plus 5 power is equal to, what is that, 62? Take the log of both sides. I'm going to now use my power property, and this has to be in parentheses because this entire binomial is going to be multiplied by log 20. If I don't put it in parentheses, it'll be m plus 5 log 20, and we don't want that. This is going to be m plus 5 log 20 equals log 62. Now I'm going to divide both sides by log 12. That will leave me with m plus 5. I don't need the parentheses anymore because it's not being multiplied by anything other than this fancy looking 1. So it'll be m plus 5 is equal to, I'm going to scroll this a little bit. This, let's see if I can duplicate that. But apparently my board is not going to let me. Log 62 over log 12. And now I just want to subtract 5 from both sides. So when I do that, I'll have m is equal to, and I'm just going to enter this into the calculator and round it to the nearest tenth. Just log 62 divided by log 12. You can put that in parentheses and hit equals, and then say minus 5. That's very important that you hit equals just before you subtract 5. Well, you don't have to, because the calculator will follow the order of operations, but it's not a bad idea. But what I'm going to do now is I'm just going to enter this just the way it looks, because when I subtracted 5 from both sides, that isolated my m. So all I have to do is put this into my calculator and hope I don't make a mistake in doing so. So it'll be log 62 divided by log 12 minus 5 equals, I got negative 3.3391118, blah, blah, blah. Then I want to round it to the 4th decimal place, 1, 2, 3, 4. Since this is a 1, that won't round up. And so this will be my answer. And that will be an approximation. I've already put an equal sign there, but I can put a dot over it, and that also means approximately. Dot there, so if I get rid of that. Yeah, alrighty. There we go. Let's see if I got it right. Negative 3.6223. Uh-oh. Did I do some arithmetic, make an arithmetic mistake somewhere? Subtracted 6, I got 62. Took the log of both sides. M plus 5. Oh, look at that. That should be log 20 right there. I rewrote it as log 12 for some reason. That's an easy fix. Let's go ahead and fix it real quick. You guys probably saw that and you were just grimacing through the rest of it. Let's go ahead and fix it. I'm going to use a power property. M plus 5 log 20. Why I wrote log 12, we may never know, is equal to log 62. Now I'm going to divide both sides by log 20. Mistakes happen. I try not to make mistakes, but dagnabbit, I make them. This will cancel and leave me with m plus 5. I no longer need the parentheses. This, just going to rewrite it. Then I subtract 5 from both sides. And that will give me m. Scroll down a little bit. Subtracting 5 from both sides equals this right here, log 62, over log 20, minus 5. I'm subtracting 5 from both sides. When I subtract it here, I'm left with m. When I subtract it here, I'm left with this. And now I'm going to try to put this in the calculator and hopefully get the right answer. It's always embarrassing when I make mistakes, but I just don't seem to be able to stop making them. Must be something about being human, I guess. Log 62 divided by log 20 equals minus 5 equals, this will be m is about negative 3.622, and I'm going to round it here in my head. This was a 2, so I'm going to leave that alone. And hopefully that's correct. If it's not, I'm going to cry. Negative 3.6223, yay! Sorry about that. I really do try not to make mistakes, but what can I say? I make them. But making mistakes is just part of math. When you make a mistake, you go back and look for it and see if you can see something that's obviously wrong, which I did. For some reason, I wrote that as a 12. Why I wrote that as a 12, we may never know. But back to the objective at hand. We're going to solve equations that have exponents in the variable using logarithms, and variables in the exponent, and you can do this.